Okay, so we're going to start off by talking about what is an integer, because this is the first time that we're talking about it for this course. And so normally when we're doing this together, we talk about it together and we brainstorm. I'm just going to go through it quickly and give some examples, and hopefully that will help. Technically speaking, integers have a very specific definition. We're not super worried about that strict definition. If we're talking about what an integer is, then yes, we will use that. Otherwise, in this course, we tend to use a bit of a looser definition. But let me start with what an integer actually is. And so an integer is a whole number. So that means no decimals, okay? And it's one that can be either positive or negative. So usually when we're talking about integers, that's really what we're talking about, is positive or negative numbers. And we're talking about, but strictly speaking, we're talking about things that are not decimals. So some examples of things that are integers, and if you want to pause the video and come up with some of your own ideas, that's great. That's usually what we would do if we were working together. We're not, so I'll just write out some examples. So how about 3, 10, a million, right? Big numbers, small numbers, those are all okay. But those three are positive. So what about some negative numbers? -7, -4. How about -3, +4? 0 counts as an integer. Things that are not integers, so decimals. So this is a fraction which results as a decimal. 3/2 is a fraction, but if you actually write it as a decimal, it's 1.5. Pi is a number that you're probably familiar with. So we're not getting into that yet, but that's a number that's not an integer. Something that's negative, but is a decimal, still not an integer. And then sometimes we have things like this, right? So that's a notation you use a lot of in elementary school. We don't use that notation almost never in high school. But it is something you're probably familiar with. So again, it's a decimal, so it's not an integer. How about something really, 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 really small? Also not an integer. Back over to things that are integers. So this looks like a fraction, and often we think of things that are integers as things are not fractions. But if I write this, I can reduce this and write it as a single number, and that is an integer. So be a little bit careful. Now, this course is not really going to be about what is an integer and what is not. So that's what I'm saying is, generally speaking, the loose definition of what is an integer and what is not an integer is the loose definition of when we're talking about integers is we're talking about negative numbers. So in this lesson, we're going to be doing multiplying and dividing of positives and negative numbers. So just to be very clear, for example, in the learning goal, there is a question that says circle the numbers that are integers. This is the only question that we're really worried about, the strict definition of what an integer is. Otherwise, we're not, if something is a decimal in a question where there's multiplying or something like that, that's okay. We're still going to do those questions. Okay. So this question right here is using that strict definition of what is an integer, no decimals, no fractions, that kind of thing. Otherwise, what we're really going to be doing in this lesson is talking about how to multiply and divide positive and negative numbers. So just to write this out, integers don't have decimals or fractions. Okay, integers are positive and negative, whole numbers. And by whole numbers, again, that's just a different way of saying no decimals. I'm not going to ask you this on a test. This is not we're not going to ask for definitions, so don't worry too much about that. As I said, for that question, for that learning goal, it is strictly talking about what a real integer is, but otherwise what we are going to do is just talk about how to multiply and divide negative numbers with positive numbers or with each other. So there's going to be two main kinds of questions, and we're also going to briefly talk about how to use exponents with integers. Okay, so notice that these first questions, there are only ever two numbers. We can use this rule, and this is a rule that you just want to memorize, and it's probably one you already know. Most people do know this rule, even if you aren't great with your times tables or that kind of thing. A lot of people know this rule, where two, let me get some highlighting going here, two positives result in a positive, and two negatives results in a positive. So you could summarize that to be, if they have the same sign, then the result is positive. And if you have positive or negative, or negative and positive, then your result will be negative. So the way I like to approach these questions is I do each I do the question in two separate parts, as it says up here, right? So I do the number part and the sign part. So we are going to multiply or divide the normal way that we would multiply or divide, and then we will do the sign part separately. Now, your calculator is absolutely your friend, and you're going to have your calculator for all these questions, but all I can stress is the more that you can do at least some of this in your head, the better off you're going to be in terms of catching mistakes, in terms of maybe being able to do some of these questions without pulling out your calculator, which is just a little bit faster. So I'm going to do the number part first. 5 times 8. Okay, so I'm ignoring the negative just for now. 5 times 8. And if you can do that in your head, great. Like I say, you're going to save some time. If not, that's okay too. 5 times 8, use your calculator, you get 40. But we're not done yet, because we have to do the second part, which is using this rule to determine the sign. And this is a positive 5 and a negative 8. And in our chart here, positive and negative, the result should be negative. And probably a lot of you already knew that this result was going to be negative. And so this should be negative 40. Now, sometimes when I'm doing these questions, I will even use a calculator to do the number part, but I'll do the sign part in my head. I won't punch it into the calculator, just because, if I type it wrong in the calculator will give me the wrong answer, and I might not be aware that it gave me the wrong answer. So, and it's also a little bit faster to just do 5 times 8 instead of 5 times negative 8, but I know it's going to be negative because I know that rule. If that doesn't work as well for you, then by all means, 5 times negative 8, you can type that into your calculator and it will get you the right answer. And this is a very good skill, to be able to type questions into your calculator really, really accurately, really well every single time, and be able to follow what the calculator says, what the question says, and punch that into your calculator. And if that works best for you, then absolutely, I think it's really important that you recognize that and that you work on that throughout this entire course, just learning how to use your calculator to your own benefit. So, there are many different ways that you can approach these kinds of questions and all the other questions moving forward. So a lot of this first unit, or the first few units of this course, are going to be you sort of recognizing what works best for you. For this one, I typed it a little bit differently from how it was written on the page. And in fact, you could type it literally exactly the same way that it is written on the page, as long as you have a good calculator like this. If you have sometimes cell phone calculators, you can't type it like this. Some kinds of cheap calculators, you can't type it like this. But if you have a decent calculator like this, then you can type it in exactly the way it looks, which is really nice and really useful. Okay, a couple more examples. Next one, 9 divided by 3. So again, I can do this part in my head. 9 divided by 3 is 3. If I can't do that in my head, I use my calculator to do that. And then I use the rule. 2 negatives makes a positive. Generally speaking, we don't have to write the positive, so you could also just write it as equals 3. When there's no sign, we assume that to be a positive. The last one, we've talked about this before when we did BEDMAS. What does it mean when you have brackets side by side or a number beside a bracket, right? So that means multiply. So this means 8 times 3 8 times 3 is 24. Again, this has two negatives, and two negatives makes a positive. You absolutely do not have to write the answer twice. I'm just showing two different ways that you could write your answer. Okay, and the other kind of question is the ones where we have more than one thing being multiplied and or divided. So let's take a look at some of these questions. Now, there are different ways that you can do these. Some people might think of them as bedmass questions where there's multiple steps. I like to look at these as do all of it in one step altogether. So I'm going to show you a strategy for that. And but you can decide which way you feel most comfortable doing it. In the end, if you get questions like this moving forward in the course, you know, it is quickest if you can do it all in one step, and you can use your calculator to do that, so that might be a good option. So what I'm going to do, again, I'm going to do this question in two parts, and I'm going to do the number part first. All of this is multiply because it's everything just side by side. 4 times 3 times 2. That gives me 24. And here's what I'm going to do. I'm going to count the number of negative signs. So this question has two negative signs, and these negative signs, these two, okay, will sort of each cancel with this chart rule. Two negatives makes a positive. So these two negatives together will make a positive. Now that they're positive, there's no negatives left in this question, and so the answer will be positive. Okay, and I'm going to move on to a couple more examples, and after we've done a few examples and seen some different circumstances, we'll sort of summarize and talk about all the different things that might happen. So this one is 1 times 5 times 6. So again, if I want to use my calculator, 1 times 5 times 6, I'm going to get 30. And in this case, I only have one negative sign. So my answer will be negative 30. There are no other negative signs to cancel out that first negative sign, right? So this is, or you could look at it like this, negative times a positive gives you negative. And then that negative times a positive still gives you negative. If I did the same thing with the first one, I would do positive times negative gives me negative. Negative times negative gives me positive, and again, that's where I get the positive answer from. Okay, another example here. Now this one's a little bit different because it has a divide in it. Remember from BEDMAS, multiply and divide happen at the same time. So you can do this in two steps, but you can also, if you get comfortable with it, do this in one step and do 4 times 5 divided by 2. And do it all together. So I'm going to do that way first, and then I'll do it the other way after. So that gives me a result of 10. And the reason why I want to do it all together is because what I want to see is I have 3 negative signs. Well, these first 2 negative signs will cancel to positives because of that rule that we were using above. 2 negatives makes positive. But in this case, I have 1 negative left over, and so I need to have my final answer as a negative. Okay, of course, you can always just type this right into your calculator as well with all the negatives and all the brackets and all the symbols and everything like that. That will work too. The other way that you can do it is by doing it in 2 steps. Now, I don't really recommend this. I like for a question like this to do it in 1 step, but again, everybody's different and everybody feels, you know, a different level of comfort. So if you were doing this in multiple steps, in this case, in BEDMAS, multiply and divide happens at the same time, so you're going to do it from left to right. So you're going to multiply the negative 4 and the negative 5 first. And negative 4 times negative 5 is positive 20. So you get 20 divided by negative 2. Positive and negative is negative, and 20 divided by 2 is 10. Again, you can do that on your calculator, or if you can do that in your head, then it might be a bit quicker. And notice I got the same answer in both cases. So 2 different ways of doing it. Okay. This one is, goes right back to before we even talked about integers. I think you start integers in grade 7 and you do them more in grade 8. And, this one doesn't have any negatives, right? So don't overthink it and start adding in negatives when you don't have to. This is like a question back from when you first start multiplying back in grade 2 and 3 and 4. And again, you just want to do it from left to right. Okay, there's no brackets for BEDMAS here. These brackets just mean multiply. So this is 3 times 4 times 5. 3 times 4 is 12. 12 times 5 is 60. So we get 60. Positive 60, there's no negatives, so we don't even have to worry about it. Okay, again, if you want to pause this video and try this one on your own, that's a great idea. And then resume the video and see if you got it right and see if your thinking was right. Notice that this is the same, 3 times 4 times 5. Well, we already know that 3 times 4 times 5 is going to give me 60. So the only part that's different is that are the negative signs. And the pattern you might have noticed is that if you have 2 negative signs, or in fact, if you have 4 negative signs or 6 negative signs, they will cancel out in pairs to positives. 2 negatives always makes a positive. So if you have 10 negative signs, they will all cancel out in pairs and you will have a positive. If you have 11 negative signs, the first 10 will cancel out in pairs, but you'll have 1 left over. So your result will be negative. So again, same for this one. 2 negatives makes a positive. I've got 1 negative left over, so my result should be negative because I had 3 negatives. 3 is an odd number, so that's a rule that you can use, and that rule is going to be helpful moving forward with the next thing that we're going to quickly go over. Okay, last example, again, if you want to try this on your own, great idea. What I can do is I can do the number part, and sometimes these numbers, when we add especially more than 2 numbers, it does start to get bigger, so it's harder to do in your head. So you might just do it on your calculator. 5 times 1 times 2 times 6. Notice I'm not putting in the negatives. Again, you can. That's fine if that's your comfort level. But I chose not to. I got 60 again. That's kind of a coincidence, but that's what I got. And what I notice is I've got 4 negative signs. So the first 2 will cancel to positives with each other, and the second 2 will cancel to positives with each other. And so I have no leftover negatives, so my result is positive. And that is how we multiply and divide positive numbers, whether you have 2 numbers or more numbers. Those are the different patterns and rules that you can use, and hopefully you can find a strategy that works for you. The last thing I want to go over, now we will go over this again, so you'll have another chance to sort of hear this discussion. But we've already talked about exponents, and exponents can be very tricky when there are negatives involved. So I'm going to quickly go over these 4 different cases, and we'll read through the summary together, and you can read through it on your own afterwards too if you want to think about it a bit further. And then we'll do some BEDMAS later on, and we'll revisit this. In the practice for this lesson, there are some exponent questions. Try your best to try a few of them, but if it's not working out, ask, but also remember we'll come back to this. So I'm going to look at these first 2, and it's -5 squared and -5 squared with brackets. And I am going to write this out long form to highlight the difference between these 2 questions. The first one is -5 squared, which means -5 times 5. Because 5 squared means 5 times itself. This one is -5 all squared, so it's -5 times -5. So notice that this one has 2 negatives, and this one only has 1, and we left it out front. And that's the difference. When you have brackets, you're also multiplying the negative 2 times. And we just finished saying how when you have an even number of negatives, your result will be positive. So 5 times 5 is 25, and I've got 2 negatives, so this one's positive. 5 times 5, is still 25, but in this case, I only have 1 negative, and that is because there were no brackets in that first one, but there are brackets in that second one. This won't come up a ton in this course, but moving forward in grade 10 and 11, it will come up more, so it's a good rule to start thinking about and start getting familiar with. It'll come up a little bit in this unit, and it is just kind of a rule that you can memorize. When there are brackets, it's going to change the question, okay? So that was -5 squared or -5 all squared in brackets. What if we do -5 cubed or -5 all cubed? Well, again, we're going to use the same rule, but we're going to find a bit of a different outcome. So in this case, in each case, I have 5 times 5 times 5. I can use my calculator for that. 5 times 5 times 5, 125, or 5 cubed, if your calculator can do that, which hopefully it can. So again, 125. So in both cases, the number part is going to be 125. So in the last example, it was 5 squared, negative 5 squared. We had 2 negatives, so it could cancel out to a positive. But in both of these cases, I have an odd number of negatives. Look, I have 1, 2, 3. Well, 3 negatives means 2 of them will cancel to positive, and I'll be left with 1 negative. Or I only have 1 negative, so my answer will be negative. So take a look at how this is different, where both answers are negative. And in this case, only one of the answers is negative. And when you compare all 4 of those, if you can make sense of that, then that does tell us all the different types of questions that we can have. Okay, and this, whether you have the number, a negative number in brackets or not in brackets, and whether the exponent is even or odd, those are all the different cases. So this summary, okay, goes over that. And if the base, so what it says is, this is when you have a negative sign, right? If you don't have a negative sign, it's totally different. But if the base of your exponent is not in brackets, so that was this one and this one, your answer is going to be negative because you only have 1 negative. If the base is in brackets, okay, so that one has brackets and that one has brackets. If the exponent is even, the result will be positive because they're going to all cancel out in pairs. If the exponent is odd, so 3, 5, 7, something like that, your result will be negative because you're always going to have 1 left over. Okay, so very quickly, let's do some more examples. Again, I'm going to use my calculator to do the number part, and I'm going to use my understanding of the rule to do the sign part. If you have a good calculator, you can type this whole thing in and just get the answer. And you don't have to show work, so that's fine if you do it that way. You just have to know how to type it in. In fact, I'll show you that in a minute. I'll show you an example of that in a minute. So I'm going to do 3 to the 4. That gives me 81. Then I'm going to think about the rule. Well, the negative is in brackets. So, and the exponent is positive, so they are going to cancel out in pairs, and my result will be positive. So if I type this in properly, watch what's going to happen. And again, these calculators are so nice because it actually looks like it does on the page. It even puts the exponent up like that. And if I hit equals, my calculator knows that I did it right. It's positive 81. What if I didn't do it with brackets? What if I was lazy, or just didn't pay attention, or didn't realize that it was important, or I was rushing and I typed it in without the brackets? Well, look at that, we got the wrong answer. Okay, and the reason is because I didn't include brackets. And without brackets, as we just learned above, the answer can be different when the exponent is even. Okay, so that's something you really do have to be careful about. So negative 8, well, let's do 8 squared, 64. And this is not in brackets, so what's our rule? The answer is negative. If you want to try these last questions, pause the video, try them yourself, and then resume the video to make sure you're on the right track. Question C, there is no negative, so it's just 4 cubed. 4 times 4 times 4, you do not have to write that out, but don't forget that's what that means. It's very easy to fall back and think that it's 4 times 3, which is 12, but it's not 12, it's 64. Okay, again, that might be multiplying. That's a little bit outside of our ability to do in our head, and that's fine. That's why you want to have your calculator and get used to it. This is a big number, negative 7 cubed. That's going to be a really hard one to do in your head. It's 343. Again, I did not rely on my calculator to do the negative part. The negative part is in brackets. That means there's 3 negatives, which means when they cancel out, there'll be 1 left over. So the answer should be negative 343. And if I write it out correctly in my calculator, I can check that work. Of course, you can always check your work at the bottom of the page. Okay, so that's a quick summary of how exponents work with negatives, whether they're in brackets or not in brackets. Again, we'll revisit this. The bigger takeaway from this lesson is remembering this rule about how we know whether our result of multiplying and dividing is positive or negative, and some practice about using that rule and some different strategies about how we can, evaluate some of these kinds of questions.